In this lesson, we will learn to evaluate logarithmic expressions. The goals for this lesson are to evaluate logarithms with positive integer solutions, evaluate logarithms with negative integer solutions, use common logarithms, and use natural logarithms. Logarithmic functions are the inverse of exponential functions. That means whenever you see logarithm, it is asking you for the exponent for which the base has to be raised to get the number x. So for instance, we consider log of 8 base 2. You would then ask yourself, to which exponent must 2 be raised to get the number 8? We know that 2 to the third power, or 2 cubed, is equal to 8. So the answer for log of 8 base 2 is equal to 3. Also, if you are presented with log of 32 base 2, we know that 2 to the fifth power is equal to 32. Therefore, log of 32 base 2 is equal to 5. Similarly, if you have log of 27 base 3, you think of exponent to where you would raise 3 to get 27. We know that 3 cubed is equal to 27. Therefore, log of 27 base 3 is equal to 3. And lastly, log of 49 base 7 is equal to 2 because 7 squared is equal to 49. So in general, if you are given with expressions like this, log of x base b, to evaluate it mentally, you're just going to convert this into exponential form. The b is going to be the base, and the y here is the exponent because logarithm is asking for the exponent, or the output for logarithmic function is the exponent for b to get the number x here. So we can convert log of x base b equal to y as b to the y equal to x. And then you can then ask, or whenever you see logarithm of x base b, you will just have to ask yourself, to what exponent should b be raised in order to get x? So let's practice here. Solve the following equation without using a calculator. Log of 16 base 4. To solve this, you just ask yourself, to which power must 4 be raised to get 16? We know that 4 raised to 2, or 4 squared, we know that 4 squared is equal to 16. So therefore, log of 16 base 4 is equal to 2. Similarly, let's solve logarithm of 64 base 2 without a calculator. So to solve this, we will just ask ourselves, to which exponent must 2 be raised in order to get 64? We know that 2 to the sixth is equal to 64. So therefore, the log of 64 base 2 is equal to 6. Now let's consider a different example. Solve the following equation without using a calculator. We have log of 1 over 216 base 6. So to answer this, it is important to think of it in exponential form. So since we are looking for the value of this expression, we will just equate this to maybe x because we don't know what the value is. And then from there, write it in its equivalent exponential form. So you think of 6 to where would you raise 6? So you would raise that to x to get 1 over 216. And since we want to know where we would raise x to get 1 over 216, it would be helpful to write 216 as a power of 6. So to do that, we can start by dividing 216 by 6 And we know that to be equal to 36. So if you divide 216 by 6, you get 36. And also, 36 divided by 6 is equal to 6. So you just keep on dividing it by 6. From there, you see that you can write 216 as 6 cubed. And by loss of exponents, 1 over 6 cubed is also equal to 6 to the negative 3. And that is equal to 6 to the x. So from here, since both of these expressions here have the same base, and exponential functions or one-to-one functions, we can just equate the exponents here. So we have x equal to negative 3. From there, we know that we will raise 6 to negative 3 to get 1 over 216. Similarly, let's solve the following expression without using a calculator. Log of 1 over 256 base 4. To do this, the first step is to write it in exponential form. So we begin by equating this to x. And then we would think of where to raise 4 to get 1 over 256. So to answer that, we will try to write 256 as a power of 4. So we will divide 256 by 4. And we get 256 divided by 4 is 64. Now 64 divided by 4 is equal to 16. And also 16 divided by 4 is equal to 4. From here, we've seen that we can write 256 as 4 to the 4th power. And using loss of exponents, 1 over 4 to the 4th is equal to 4 to the negative 4. So if 4 to the x is equal to 4 to the negative 4, it follows that x is equal to negative 4. So this expression here is equal to negative 4. Sometimes you may see a logarithm written without a base. In this case, we assume that the base is 10. In other words, whenever you see log of x, this means log of x base 10. So the base 10 logarithm is called a common logarithm. Common logarithms are widely used in science. This is used to measure the Richter scale or scales using the brightness of stars and the pH of acids, and maybe some other applications in the science field. So with that, when we are to solve for expressions of the form log of x or y equals log of x, to evaluate this mentally, you're just going to think of where to raise 10 to get this number x here. So the exponent here is y, the base is 10, and the number is x. So we will rewrite this expression here as 10 to the y equal to x. For instance, let us evaluate log of 10,000. So to evaluate this, we will just think of where to raise 10, because we don't see any base here. That means that this is a common logarithm, that the base is 10. So we would think of where to raise 10, to get 10,000. Now, you know that 10,000 is just 10 to the 4th power. So therefore, y is equal to 4, or the answer for log of 10,000 is equal to 4. Another example, write the exponential equation 10 to the negative 4th as a logarithmic equation. So to do this, we will first expand 10 to the negative 4th. We will write that as 1 over 10,000. Now we have this equality here, we have this equation here. Then we will use the definition of logarithm, that is, if you have log of x base b equal to y, equivalently you could write this as b, that's the base, raised to y equal to x. Now in here, the base is equal to 10. That is why you don't see any base here, because for common logarithm, we don't need to write the base 10. Now, the number is then 1 over 10,000. That is your x. And you have here 1 over 10,000. And that is equal to the exponent for 10. That is where you would raise 10 to get 1 over 10,000 is equal to, that is equal to negative 4. So therefore, the expression 10 to the negative 4 equal to 1 over 10,000 may be written in logarithmic form as log of 1 over 10,000 equal to negative 4. Finally, the most frequently used base for logarithms is e. E is a constant. This is a prime number, and we use this, or this is commonly used as base for logarithms, and this has important applications in calculus and some other scientific applications. If the base is e, we call this logarithm the natural logarithms. So whenever you want to mean log of x base e, you write the notation for that is ln. So ln just means log base e. So ln of x means log of x base e. Now, since the base for ln is e, therefore most values of ln can be found only by using a calculator. But with the exception to that is ln1. ln1 is equal to 0 because using the definition of logarithm, when you say ln1, we know that ln1 is the same as log of 1 base e. So we would think of the exponent, or where we would raise e to get 1. And we know that e to the 0 is equal to 1. So therefore, ln1 is equal to 0. Other than that, we would need a calculator to find the value of ln. You can use the ln key that you can find in most scientific calculators to evaluate the natural logarithm. And we can also find the natural logarithm of any power of e using the inverse properties of logarithm. So whenever you see this expression y is equal to ln x, you can convert this to e to the y equal to x. And from there, you can use the loss of exponents and other properties of exponents. So in summary, for x greater than 0, y equals ln x is equivalent to e to the y equal to x. And we read ln x as the natural logarithm of x. The logarithm y is the exponent to which e must be raised to get x. Now, since the function y equals to e to the x and y equal to ln x are inverse functions, from there we know that ln of e to the x is just equal to x. And also, e to the ln x is equal to x for all x greater than 0. So now to evaluate natural logarithms, we use the calculator. We begin by pressing or looking for the function ln, and then you enter the given value of x, followed by a parenthesis or a bracket, and then you press enter. That is how you would find the value for ln x. Now let's take a look at this example here. We write e to the x equals to 40 using natural logarithms. So this is in exponential form. We're going to write it in logarithmic form. The base here is e, therefore we use the natural logarithm ln, and the exponent is x, the number is 40. And so with that, we have log of 40 base e equal to x. Now we write, if the base is e, we write, instead of writing it as log base e, we will just write this as ln. So ln of 40 is equal to x. Next example. Evaluate ln 8 using a calculator and round to the hundredths place. So to evaluate this using a calculator, you just have to locate the function ln in your calculator and then press 8. And then whatever the answer is, you will round it off to the hundredths place. The answer is 2.08. So next, I'm also going to show you how to use a scientific calculator. In particular, we're going to use the ClassCalc calculator. This will be available to you during test inside Proctorio. So for instance, let us evaluate ln. So to evaluate ln, you just have to click on this function here, say ln of 8, and then close that in a parenthesis. This is the answer here. And then you can round this off to the nearest hundredth if you need to round this off to the desired decimal place. And then you hit enter to get to the next line. So suppose you want to evaluate ln of say for instance 50, ln of 50, and then close that in a parenthesis. This is going to be the answer. Now you can also evaluate logarithm with any base using this function here. And this function here is for the common logarithm. So for logarithm at any base, you can assign the base. For instance, the base is 2. We know we want to compute for the logarithm of 216. Okay, so we don't have an exact answer for that. Or let's consider something that is a power of 2. For instance, log of 64. We can compute this mentally, but you could also compute this using the calculator. So you just have to input the base here and then the number. And then this is the answer. Log of 64 base 2 is 6. For instance, you want to get the common logarithm of 10,000. 10,000. That is equal to 4. We can compute this mentally, and the answer is 4. You could think of where to raise 10 to get 10,000. So you know 10 to the 4th is equal to 10,000. So suppose we want logarithm base 2 of, say for instance, fractions. Think of a fraction. Let's say, so if you want the fraction, you can also use, you can just write this, for instance, 1, and then divide it by, that would immediately form a fraction. So we have, for instance, 1 over 128. Okay, so this is the answer. Log of 1 over 128 base 2 is equal to -7.